Hello, I thought I'd shoot a little video about firewood. We're not going to go into specifics of calorific values, etc., just into generalities. How different types of timber behave, depending on the species, and how they're grown. And things like, why burn wood? Why not burn coal? Why not burn peat? As you've probably seen from some of my other videos, I burn wood. And I don't burn coal on principle, because basically wood burns a lot cleaner if it's well seasoned and well dried. The amount of pollutants that it gives off is minimised. It's not to say it gives off no pollutants, but it's a nice sunny day today and my fire is running at the moment, and it's the left hand of those two chimneys. Basically, unlike burning coal, which gives off a lot of sulphur, oxides and sulphides, burning wood gives out very little smell. You're also burning in-cycle carbon. If you're burning coal or gas or oil, you're burning fossil carbon, which is usually sequestered down in the Earth's crust away from the biosphere. It is removed from the life processes of the planet, to put it slightly grandly. But burning this stuff would rot down anyway eventually. Some people say that by planting trees you're locking up carbon. No, you're not. You're capturing it, but unless you put your timber, your trees, into the ground, away from biological processes, you bury them or you make them into timber and then use them as heritage furniture, make them last a long time where they again don't rot, you're not sequestering carbon. So most of what I burn, as you've seen from some of my other videos, is hazel. This is all hazel. It's a fairly dense wood and it's a hardwood. Hardwoods basically in temperate areas are deciduous trees. Softwoods tend to be conifers. This is a bit of pine. And you can possibly see from the way I'm hefting this is fairly light. It goes fast. You can see the annual rings are widely spaced. And there's also a lot of resin in this. The resin is the way the tree responds to damage. It floods a damaged site with resin, basically hoping to seal it up and capture any insect invaders. Hardwoods don't do that. They don't produce so much resin, or they do produce small amounts. They basically use wound compartmentalization to block off areas that have been damaged and stop any infection getting to other parts of the tree. Two different strategies. And that affects the way the timber's formed and the way it behaves when it's burnt. That's a bit of Scots pine. Hazel, hard, dense, and this has all been seasoned for 2 years and then dried. But you can see it looks different because there's some other species here, and also some of the hazel was probably seasoned standing when it was cut. So it was already seasoned, then kept out in the wood for 2 years before it was put under cover like this. Such as this. This is hazel and this is spalted. So this has been infected probably whilst it was standing and while the tree was partly alive. So this section here was probably still alive when it was cut down. And it's been infected by fungi. And you can see lots of different patterns. And this is probably several different individual fungal mycelia. The mycelium is the little threads of fungus which actually invade the tissues of the tree, and they basically break it down to carry on its life processes and its own reproduction. So what the tree does is basically uses photosynthesis to take water and carbon dioxide to make simple sugars, glucose, then elaborates those sugars using more energy via different pathways, again captured from photosynthesis, to make cellulose, which is a very complex sugar or an elaborated sugar, and other compounds such as lignin, plus all the other things it needs to survive and to thrive and eventually to reproduce itself. What the fungi do is the reverse of that. Instead of adding energy from sunlight to carbon, hydrogen and oxygen and other minerals, it actually breaks those bonds down to release energy, carbon dioxide and water vapour. This is spalting. It's valued by some turners because it makes pretty patterns. But you can also tell if you've got spalting, your wood has started to break down. It's losing some of its calorific value, some of its heat value. When you get like this is a bit of ash, this is extremely light. If you compare it with this, which is a bit of hazel, you can also stick your fingernails into this, and basically this is broken down to a large extent. This will burn extremely quickly, won't produce very much ash, but if you were making charcoal out of this, trying to make lumpwood charcoal out of this, you'd be on a hard into nothing, because all you get is basically charcoal dust. But it will burn. If it's dry, it'll burn clean. So that's spalting, that's rotting, and what you're trying to do by seasoning is to minimise the amount to which your timber is broken down and maximise its dryness, i.e. minimise again the water component. There's two components of water in a freshly felled tree. You've got the life water, which is the water within the tissues, which is the medium for all the life processes, and that's in the underbark, it's in the phloem, and it's in the xylem. And that's the water the tree also uses to transport nutrients and sugars around itself. Seasoning is the getting rid of that life water. When seasoning is finished, the tree is definitely dead, and a log like this can continue respiring for quite some time because the bark tends to conserve the water. Not many trees like ash, just under the bark in the cambium layer you will have photosynthetic cells. But once the tree has died completely, life processes are finished, seasoning is then complete, the life water's gone, you then start to dry it down. Dead piece of wood can take up moisture from the surrounding areas, which is why you cover it up for the last part of the drying. Let's have a look at some of the timbers that are here. This is hazel. Dense wood, calorific value is fairly high. This is cherry. If we pop that down there and put a bit of hazel next to it, you can see the difference in the bark. Both of them have these horizontal structures, which are basically called lenticels, and these are the things which the trunk of the tree uses, or the tree uses for the tissues of its trunk to exchange gases with the atmosphere around it, so take in oxygen to survive and to respire, and to give off carbon dioxide, which is produced as a result of respiration. And the hazel has got this greyish greenish bark. It's usually greyish greenish when it gets to this size, and cherry is more brown, but it's got this sort of silvery sheen, and the lenticels going along here are much bigger and more noticeable. If we look at ash, which is this one, you can see it's different again. It tends to break up into platelets when it gets slightly older, but it's more grey brown, and you can't really see lenticels on it at all. That is a well gone bit of hazel. I thought it was a bit of birch, because birch has a bark which is more or less this colour. Two species of native birch, and bark slightly different colour in both, and they have a similar structure to this. Also in cherry you've got hardwood and sapwood, and they're different colours. Not all trees have that. Hornbeam doesn't, ash doesn't really, that's an ash there, and hazel doesn't. Over here, also no heartwood and sapwood. This is a little bit of apple, which is a fruit wood, all fruit woods. So it's trees which actually produce fruit that you or the birds can eat, such as apple, such as hawthorn. All fruit woods burn very nicely, and they burn fairly cleanly, reasonable calorific values, and some people say they give off a nice smell. At the moment, as you might be able to tell from my voice, I can't smell anything, but I understand that this is given to be true. Right, what else have we got in here? This is a bit of oak. Again, different. I think it should be that way up. And you can see what oak is famous for: the hardwood, which is naturally durable, heavy in tannins, which are natural preservatives, and the sapwood around the outside. And it should be, yeah, here we have a bit of yew. Know how closely grown this is? Yew is a conifer, so you would expect it to be a softwood. And indeed, if you do lump stuff together, you would call it a softwood. But it's actually very hard, very dense wood, because it is so slow growing. And it actually burns and behaves in terms of its properties as timber, more like a hardwood. Some of you might have seen this little chap. And he's here. He's not a lizard, he's actually a crocodile. But he's here basically to remind me to say that when you're doing your seasoning in your garden or your yard, don't neglect the possibility that your piles can be home to various things over the winter. Not people. So things like common lizards and slow worms might end up hibernating underneath your stack. Butterflies too. In the UK, small tortoiseshell and peacock are two well-known butterflies that will overwinter as an adult in piles such as this. So when you take your piles apart, do it nice and gently and gradually. And if you find something, then relocate it, preferably to as similar a place as you can in a pile that's not going to be used that year. And it may well survive. Then come the spring, it'll start to fly and reproduce and give your garden an extra feature. Hope that made sense, and I hope it was useful. Thank you very much.